Hello everyone, welcome to the webinar about demystifying coding in the primary grades. My name is Erica Armstrong and I will be with you during this next hour to tell you a little bit more about coding and how to get started with it. This webinar is definitely for beginners. It's for those of you that maybe have never done coding before or have done very little of it and want some help with learning more about it. I'm currently a teacher with the Near North District School Board. This past year, I taught grade 1 French immersion. And then prior to that, you may also know me from being a teacher with the Peel District School Board. And while I was there, I did a number of roles, but one thing I did was to teach in a position that was a rotary position where I taught a lot of primary classes coding. And so I'm going to share with you some things I've learned, and hopefully it'll help you out. Before we get started, I do want to read ETFO's land acknowledgement. In the spirit of truth and reconciliation, the Elementary Teachers Federation of Ontario acknowledges that we are gathered today on the customary and traditional lands of the Indigenous peoples of this territory. And I've put a link down below in the speaker's notes to a really great website to find out more about the traditional land that you may be on. And this is the human rights statement. The Elementary Teachers Federation of Ontario is committed to providing an environment for members that is free from harassment and discrimination at all provincial or local federation-sponsored activities, fostering the goodwill and trust necessary to protect the rights of all individuals within the organization, neither tolerating nor condoning behavior that undermines the dignity or self-esteem of individuals or the integrity of relationships, and promoting mutual respect, understanding, and cooperation as the basis of interaction among all members. Harassment and discrimination on the basis of a prohibited ground are violations of the Ontario Human Rights Code and are illegal. The Elementary Teachers Federation of Ontario will not tolerate any form of harassment or discrimination as defined by the Ontario Human Rights Code at provincial or local federation-sponsored activities. So, why teach coding and what is it exactly? From our perspective as Ontario primary teachers, we, of course, need to teach coding this year as it's now part of our math curriculum. But beyond just because we have to, why should we? There's a number of ways you could look at this. One is that you learn so many different skills through learning coding. There's a new strand as part of our math curriculum that's all about social emotional learning. And that strand is meant to be woven throughout all the other strands. So as your students are learning about coding, you can also be pulling in those social emotional learning skills. Things like problem solving, creativity, collaboration, and communication. You're going to see a lot of those things as you learn coding, and those are all transferable skills. If you get better at those, that's going to help you not just with coding, but with all kinds of things in school and in life. So another aspect of why I learn coding is just to have a general understanding of how the world around us works. Our students learn all about science. Not all of them are going to go on to become scientists, but having that base of knowledge about how science works and how it impacts our world can help us be more informed citizens. And now more than ever, that's so important. And it's the same thing with learning about coding. Technology is everywhere and it impacts us greatly day to day. So the more we can understand the behind the scenes of how things are working, the more we can be more informed about what's going on. And that's just great for our general knowledge. Now, for some students, they may go on to pursue coding more than just what we teach them in elementary school. And if so, there are tons of opportunities out there for people that pursue computer science, or CS, as you'll see it referred to throughout the slide deck. There's also a huge need for a more diverse workforce when it comes to computer science. And we know that by exposing children to computer science when they're young, it gives them that opportunity to continue to pursue it, versus if they'd never been exposed to it, they might not choose to.
Software and computers. It used to be that was just kind of a separate area of the world, but now software touches all these different things that you use.
I think if you look in everything, I mean, there's more phones and tablets and laptops and websites, and everybody's on social media, and I mean, it's just all these different things, and everything's just moving faster. So just being in a position to kind of understand that language that's going to be the future. I mean, I think it's a good thing to do.
It's absolutely crucial to know how to code and to understand how technology is built, even if you don't choose to, make a living or be a full-time software developer. Understanding how software works, which is something that affects everything around you, from your purchases to, how you eat and just how everything works nowadays, it's really important to be able to know how it works so that you are not sort of a victim of other people's choices.
It's important for these kids right now, starting at 8 years old, to be a citizen on this planet. Hey, whatever country you're from, to read and write code.
If you wait until you're an adult, you probably will never do it.
I always felt like if I didn't learn how to program, it would be like not learning how to read. The future would just be closed to me.
When I think about what we're going to be teaching in schools 5, 10, 15 years from now, I definitely think that computer science, or at least basic programming, is going to be as important of a skill as being able to do basic reading and writing. And I think we're going to look back and wonder why it took us so long to get to that point.
So there you go. You don't have to just take my word for it. It's definitely just an important skill all around. So as we become beginners, I want us to just define some terms so we're all on the same page. Computer science is the field of study of which coding plays one part. Computer science has many components. Coding is not all of computer science. There are other elements to it, but it's one piece of it. And so you'll hear that term quite a bit. Another thing you'll hear a lot is talking about computational thinking. These are those skills that I was mentioning earlier that could be transferable to other things besides coding. But specifically, it's that ability to think more like a computer. And it's going to include things like decomposition, that ability to take a larger problem and break it down into its chunks. And that's going to be an important skill, even just in mathematical problem solving or any kind of problem solving. Pattern matching, abstraction, that ability to take something complex and make it simpler, make it easier to understand, and again, breaking it down. And algorithms. So algorithm is a term you'll hear a lot in coding, and it's a term that we're already familiar with from mathematics in general. And simply, it's just a list of steps to finish a task or problem. Code is then the language that programmers use to write steps in a way that a computer can understand it. And then coding is putting those two things together. It's taking an algorithm, which isn't necessarily written in code, but then taking that code, that language a computer can understand, and writing it and putting it together. So you're translating that algorithm into something a computer can understand. So coding, like most creative processes, has a cycle, and it's going to be familiar to you if you've ever used the scientific process or just even the writing process. Everything has this kind of cyclical process. How many times can I say process? But anyways, you're going to start out by defining that problem or goal that you have. You're going to create a solution, test the solution, reflect, did it work? And then refine or do it again and go from there. And the great thing about coding, as compared to some of those other processes we're more used to, is that it happens so fast. So even in a one lesson, you're going to go through this coding cycle, dozens, if not hundreds of times as you test and try out the different things you're learning. So it's a great way to practice those reflexive skills. Now, for us to begin learning about coding as beginners, we're going to use something called block coding. And the reason why we do that is that it lets us focus in on those thinking skills. It's going to take away some of the complexities of learning a particular coding language and let us do it in a way that looks more like this. As you can see over here, this is an example of block coding. and it's written in a way that we can understand it either in English, or we could also do this in French, or your students could also do it in a different language. If they're English language learners and want to do it in their home language, they can. So that way we're not struggling with the language of coding. We're focusing on those processes and the thinking. And this part is a little bit easier for us. And that's great because that helps us, not worry about typing properly and our whole code not working just because we made a typo. Coding languages also have a very particular syntax, the order in which you have to put the instructions for it to work properly. And using block coding lets us avoid some of those pitfalls. Now, if we ever do move on, or our students ever do move on to using a coding language where you're actually typing it all out, not a problem at all, because you're still able to transfer over all of those thinking skills. So it's not like you're going to be starting over from scratch. You're going to build upon what you learned with block coding, and it's going to make that next step even easier. So when we're thinking about block coding and introducing it into schools, there's lots of different options. So this screen is overwhelming because there's a lot on it, but by all means, this is only one fraction of what's available and possible. But I do want to encourage everyone to not get stressed out about having the right tool for block coding. There's Scratch, Scratch Junior, Code.org, Codable, CodeSpark Academy, and if you're following along with this slide deck, you can click on all of these and it will link out to the website where you can learn more about that particular tool. You might also see things like Spiro or Dash, or WeDo, or Microbits, or Osmo Coding, or Makey Makeys. Those are all ways to take what you're learning with block coding and see the results physically in front of you. By all means, you do not have to do that. In fact, I would encourage you, if you're starting out, to not worry about that yet, or even at all necessarily, especially right now in a time of a global pandemic when we shouldn't really be touching and sharing things. We might not be able to integrate those toys in the same way we could otherwise. Those toys can be great and fun and engaging, and I do like them, but they can also be expensive and hard to share, and they can distract from those thinking skills we really want to focus on anyways. I have had lots of success using them in special education settings where students may need a more concrete representation of what they're doing. So there is a time and a place for everything, and by all means, they're tons of fun. So if your school does have them already, make use of them. But I wouldn't worry about going out and spending a lot of budget on something like that if you don't already have them, especially in this context we're in currently. So for the purpose of today, and for what I suggest you start with, we're going to focus on two tools. One is called code.org, and I really like it because it's very guided, and it's going to step you along slowly but surely and kind of teach you as you go, which is very nice. The courses are already all pre-done for us. As teachers, we just kind of pick which course and which activities we'd like to do with our students. But then after that, all of the work is done for us. And they have some very engaging themes with different characters from movies that our students really like. So that can be very engaging. The downside to that is that you're stuck with what they've pre-done. So there's not really a lot of flexibility there. So for that reason, I also want to introduce you to another tool that's called Scratch. And Scratch is completely open-ended. They do have some pre-done tutorials and things. They're already there, but you can go beyond that. It's more sandbox style. You can create whatever you like. And the reason I've chosen both of these is because they're both free, and they're both device neutral, meaning if you've got Chromebooks or iPads or no matter what you have, you're going to be able to do these. You don't need anything special. You don't need to install any apps. They all run through a web browser. And importantly too, is that neither of these tools require accounts. So I know all of our boards have different policies around third-party tools, but no matter what your board's policy is, you'll be able to use either of these just by going on the website and visiting the website. Both of them do have the option to make accounts, And based on your own school board's policies around privacy and data protection and whatnot, you can decide whether or not you want to. But for the purposes of what we're going to do today, everything I'm going to show you, there's no real benefit to having an account. So that's easy. So as I've already mentioned, we have this new math curriculum that we're adjusting to, and a lot of it is familiar, but definitely this coding component is brand new, and it's a part of the algebra strand. Now, the overall expectation is the same for all grades, and that's great news for those of us teaching a split grade or teaching in a rotary position where we're teaching multiple grades, because that makes it really flexible for us. We don't have to worry about a different expectation for different grades. And that overall expectation is that we're to solve problems and create computational representations of mathematical situations using coding concepts and skills. So just a fancy way to say we're going to use coding to solve some problems. Now, if we dig into the specific expectations, you can see that there is a suggested progression of skills as we move through the grades. So when we're starting out in grade 1, they're suggesting that we're working with coding that involves sequential events. Then when we move up to grade 2, sequential events are still there, but we're adding on concurrent events. Then in grade 3, again, we're just stepping a little bit further by adding in repeating events. But you can see the entire language of all the rest of the expectation is completely consistent from grade to grade. And this is also reflective of the fact that when we're coding, we can't really code in a silo. You can't really do repeating events without also doing sequential events. It's all intertwined, it's all built together. So you're going to find, even in the examples I'm going to give you, I'm going to try to give you some examples of each kind, but other things are going to sneak in there. You can't really separate one from the other sometimes. So don't stress or worry too much. If you're a grade 1 teacher and you end up also including a little bit from grade 2 or grade 3, no big deal. You're going to focus in on and assess that grade 1 skill, but you may end up including some of the other skills also. And that's just natural. That's just how it goes with coding. Another thing I wanted to point out is, again, this social emotional learning strand. And pretty much all of it can apply to coding, but this particular piece stood out to me and I wanted to highlight it. And it says, recognize that testing out different approaches to problems and learning from mistakes is an important part of the learning process and is aided by a sense of optimism and hope. So when we're coding, especially if we're new to it and it feels a bit intimidating to us, we need to have that sense of optimism and hope. We are going to figure it out. We are going to make mistakes, and that's going to help us learn. And in fact, we're not going to become good coders unless we make a lot of mistakes. That's just a natural and important part of the coding process. So embrace that from the beginning. Make sure your students know that they're going to make mistakes, and that's okay. And in fact, it's needed, it's necessary. So you're going to be able to, as you get going, get really creative with coding. Don't worry too much about this to start with, but pretty quickly you're going to see that you can pull in pretty much any strand of math. There's some really strong connections, of course, to spatial sense, and you'll start to see those right away. But there's also connections to all the other strands too. You're going to easily see how you can pull in language. As we were talking about algorithms, some of you may have already started to think about procedural writing. You know, that's a form of writing where we're writing things in steps, and that's exactly what we do with coding algorithms. So there's a real natural connection between those. You can also really easily do a lot of different storytelling. And same with the arts. You can pull in music and use coding to compose music. You're going to create all kinds of animations, and so you're pulling in art that way. You can even end up, if you get really creative and fancy, you can even draw your own characters. You know, take a picture of them and import them into your coding environment. And so now you're coding your own character that you've drawn, which is so neat. And then, of course, there's connections to drama too, because as you code these different characters, you can work on their dialogue and have different voices with them. And you can get super, super creative. So even though coding is just one piece of one strand of the math curriculum, you're going to find that your students love it and they're going to want more of it. So being able to pull in these expectations from other areas of our curriculum will mean that we can devote more time to it and still be able to cover all these other things that we need to get through. So enough of my background chit chat. I want to get right into it and show you some of the really cool things we can do. So sequential events, starting in grade 1 and moving on. Again, sequential events is just a matter of being able to take this problem that we want to solve, break it down into its component parts, and be able to put those instructions in order so that we can accomplish our goals. So as you're teaching coding, you don't always have to use technology. You can do it unplugged. You do want to make sure that you don't only do coding unplugged. You do need to get to the technology eventually. But certainly as an introduction or as a way to make connections, you can certainly do some activities that are off device. And one thing I like to do with sequential events, especially as we get started, is play human robot. So I often start out by being the robot as the teacher, and I present my students with a goal. Maybe I've got some red blocks and I need to move them over here into a bowl. And so I get the students to volunteer to tell me what to do. And they can't just say, put the blocks in the bowl. They have to tell me step by step. Stick your arm out, open your hand, put your hand down, close your hand, lift it up, move it over. And I make them tell me the steps very step by step. And I do exactly what they say. And I make a big, drama and exaggerate it if they tell me something wrong or they skip over a step. We'll bump into stuff or laugh about it and make it really fun. But just to get the point across that when we start to code, computers can't make sense of what we say unless we tell them specifically what to do. I've seen too, if you have one of those hundreds rugs in your classroom, those rugs that are all like the grid, or even if you have tiles on your floor that are squares, or I've seen some people do with tape. You'll tape out a grid and you'll put some obstacles in the way of the grid, and you'll have like a maze where you start at one corner and you have to direct your partner to get to the other corner by saying things like move forward, turn to the right, move forward, step backwards, move to the left. Whatever you need to be able to direct the one person through the maze, avoiding all the obstacles. And that unplugged example is very much like our first coding example, on computer coding example. So this is code.org, and I've linked directly to one of their courses. And so they often start out with a video, which I won't take the time to play right now, but you can follow along and try it yourself and watch the video. Great thing about the video is that it's a little lesson that your students can play in order to know what to do next. So code.org courses make great opportunities for distance learning if you end up in that situation that you're going to need to do that this year, because it's very guided and the instructions are built right in. But for now, I'm just going to skip right past it. And up here, they have the instructions for the level, and I'm just going to move my picture for a second to show you that for our students in grade 1, or for any struggling readers, there's actually a play button right here that will read the instructions out loud for them so that they don't necessarily have to read it themselves, which comes in handy. And so with all of these levels, you've got your bird, and he needs to get to the pig. And so it's very sequential. They kind of hold your hand with code.org. So they just told me to snap those blocks together, which I did. And now I need to hit run. And it's fun and it's quick. And right away we're feeling that success because we've already coded our first level. So now it's saying I need an extra move forward block to finish this one. So I've got to snap these ones together and drag one more over. Now let's say I did that and I didn't quite snap it together. And I hit run. Uh-oh, I didn't quite make it. And it's going to tell me that something's not quite right yet. And this is what I'm talking about by needing to make mistakes to learn sometimes. So quickly, we're learning that, oops, wait a minute, they do need to be snapped right together. So you just reset, run it again. Great, and continue. So you can see how these levels are very easy to start with, and just as you go on to each new level, it becomes slightly more hard, just by a little bit each time, which is great. So this one says there's an extra block, so it's teaching you to pull down to separate them, and you can just drag it over here to delete it. Snap these back together. And part of this too is just for students to get used to those mouse skills necessary to be able to drag and drop blocks around. Especially for our littles in grade 1, if they're doing this on a Chromebook, using a touchpad to drag and drop can be very tricky at first. One thing I teach to all of them is to use 2 fingers on their touchpad. Most of them just like use 1 finger and they push down really hard and they're like trying to drag the blocks along. And a lot of them do manage. But for those that struggle, if you teach them to click down with 1 finger, and that's the one they're pushing down with, and then with the other finger, they're not pushing down, they're just gently moving their finger along, they can more easily drag and drop things. So that helps some of our littles, especially with Chromebooks. All right, now this one is kind of the first level where they've taught us some skills and now they're leaving us to figure it out on our own. So I've got a bird, got to get to the pig. All right, what's the first thing I need to do? Well, I'm going to move forward. I think that's right. But before I add more blocks on, I often want to run it and just to see, am I on the right track or not? Okay, yeah, that's a good start. Not done yet, but it's a good start. So I can reset and I can think to myself, okay, what's going to be next? I think I'm going to turn left. Okay, I'm going to test it to make sure. Oh, no, you know what? That's not the right way. I needed my bird to look the other way. So I can actually come along here and I can change from left to right, or sometimes the student will delete the block and add the other block back in. That's fine too. Good, okay, that's good. So do you see how I am adding 1 block at a time? That's a strategy I use with students and I model to them because sometimes they'll add like 5 or 10 blocks and hit play and it won't work, and then they'll be kind of stuck with figuring out where the problem was along the way. If they just add and test and add and test and add and test, that will help them make sure they stay on the right track. Something that's tricky for a lot of our youngest learners is that perspective taking. It's not my left and right, it's the left and right of the bird. So that can be tough for them to grasp at first. They will catch on though. And especially with this, with trial and error, if you try right and it doesn't work, you know it's left. So it won't take them long to figure it out no matter what. And they'll get better at that perspective taking as time goes on. So what I'm going to suggest is that you pause the video at this point, click on that link in the slide to these Angry Birds levels, and I want you to try to do all the levels. So I've shown you up to level 5. See if you can figure out all the way to the end of this lesson. And just experience for yourself what it's like to learn to code. And then once you've done that, come back and keep watching the rest of the video. All right. Okay, I hope you've gone and done that. Now I'm going to show you an example with Scratch. Now, like I said, Scratch is much more open-ended, but you're going to see it's very familiar as far as the blocks go. So over here, it's much like code.org. We have tons of blocks. Unlike code.org, code.org limits you to show you just the blocks you need. This has all the blocks at all times. So you have to pick and choose through them what you need. And that can be trickier. But you can also do a lot more with it, which is exciting. So here is Scratch the Cat. This is kind of our little area where we see what's happening. And he's called a sprite. And you can actually add different sprites. I'm going to choose an animal. Oh, maybe the little chick. And I'm actually going to get rid of Scratch because I don't want him for this one. So there's my little chick. And she's just on a plain white background right now. You can actually come down here and choose a different backdrop. Maybe she is... oh, in the garden maybe. So you can see already how much more creative you can be with Scratch versus code.org because you're choosing everything yourself. So you can easily tie in other curricular areas. Your science curriculum, you can have students animate or create something that fits in with what you're learning about there. So there's so many more possibilities. So I'm going to come over to events. And I'm going to get a block right here that says when the green flag is clicked. And then I'm going to start connecting other blocks to it. What do I want to have my chick do when I hit go? So motion, look. So I'm going to start with look. Say hello for 2 seconds. Okay. I'm going to have my chick say hello. And then maybe I want her to move. Maybe not for 10 steps. Maybe she's going to move for 50 steps. And then, I'm going to have her say something else. Maybe have her say goodbye for 2 seconds. Okay, super simple example, but you can see how I am slowly building in the sequence of what I want her to do just by adding more and more blocks to the bottom. So like I suggested with code.org, let's test it out before we add anything else. Okay, she said hello, move 50 steps, and then said goodbye. Now I'm noticing that 50 steps wasn't actually very far. I kind of wanted her to get all the way over to here. So I'm going to change 50 to maybe 500. That was better, I guess. So as you can see, as you start to work with Scratch, you can start to get very creative and do all kinds of different things. And you just kind of have to figure out by trial and error maybe, or maybe by doing some tutorials what all those different blocks do. So it's great for story retells or even inventing your own stories. All right, we're going to move on to concurrent events. So concurrent is very much like sequential, except now you can have more than one set of instructions going on at once in your code. So sequential was very much just, you had your when the green flag was clicked, and underneath of it what would happen, and that was it. With this, you could have multiple sets of sequential instructions. So an unplugged example, a way to kind of relate this to something that might be easier to understand, is to listen to some classical music. And can you pick out what the violins are doing, what the piano is doing, and hear how all of those instruments are playing different things, but together, concurrently, they make something really beautiful, even though it's all different. So that's kind of the idea with code. You could have different characters doing different things, or different sets of code doing different things, but together it makes something cool. So there's a couple of examples on code.org. I'm going to show you the Flappy Bird game, but you could also check out the dance party. It's a little bit tougher, dance party is. This one I find is a little bit easier, but you may have some students ready for the challenge.
Hey everyone.
All right, again, it starts with a video. I'm just going to skip it for time, but you can watch it. So attach a block to the when click block and then press run. Okay. So when I click, I want it to flap. All right, So you might have played this game back when it was popular a while ago, but essentially we get to build it ourselves. So that first level was just sequential, but now you can see how it's starting to get concurrent. So I have some instructions for when I click on the game, but now I also have a set of instructions over here for when I hit the ground. And different things will happen depending on what I do. So when I click, it's going to flap. You can even have it play the wing sound also. And when I hit the ground, I want the game to end. And maybe there's a sound here too. Sad sound. That sounds good. All right, let's try it. Ah, it works. So this time we're adding, and I'm just following the instructions right here. I'm going to set the speed to normal and flap. Okay, and so you just continue on, but you're starting to get that concept of you can have different sets of instructions in your code. So I'm going to suggest the same thing I did last time. If you're following along, pause the video here and see if you can finish the rest of the Flappy Code levels. Have some fun with that. All right, are you back ready for some more? So I wanted to show you with Scratch that you could do a similar thing here as well. So if you were doing storytelling, you could do it with multiple characters. All right, so maybe I have the cat and the bear. And the cat and the bear are going to interact in my story, but each of them needs their own set of instructions to be able to work. So you'll notice right now, I have the cat selected down here, and you can see even right here, the cat is just lightly highlighted in the background. If I click on the bear, up here you'll see it changes. So I could have one set of instructions here for the cat. When the green flag is clicked, we're going to meow. We're going to say hello. And then on the bear, when the green flag is clicked, I don't need a sound maybe. And the bear say hello. And maybe just for the fun of it, I'm going to show the bear spinning. So now when I hit the green flag, you can see both those sets of instructions run at the same time, making two different results for two different characters. Now, you could also do one of my favorite activities with Scratch, which is to make a little dance party. So I'm actually going to get rid of this and get rid of that. I'm going to pick a fun backdrop because let's have a dance party somewhere fun. There we go. That looks like an appropriate setting for a dance party. Now I'm going to add a character, and they conveniently have a whole section of sprites called Dance, which has different dancers. So there's one. I'm going to add a second person as well. Alright, now scale-wise, I want to maybe make that one just a bit smaller. There we go. Okay, we've got two dancers. Now, the cool thing about our characters or sprites in Scratch is they have different costumes. So I can click over here to costumes, and I can see that Cassie here has these different poses. And we can actually animate them to make something neat. So when the green flag is clicked, I'm going to have her switch to her next costume. And then maybe wait a second. Go to the next costume. wait a second, then maybe I can choose like a particular costume, so maybe I want to have her go back to that first one. Anyways, you get the idea. I could keep going and add as many instructions as I need. And now on my next character, I want to do something similar. When the flag is clicked, we'll go to the next costume, wait. For the next costume, wait again. And there we go. All right, now what's a dance party without some music? So I'm actually going to add some more code. So when the green flag is clicked, I'm going to add a sound. I'm actually going to choose a new sound. All right, that sounds more like it. Dance funky. So when the green flag is clicked, you're going to play Dance Funky until done. All right, so now I think I know what's going to happen. Let's hit the green flag and see. All right, there's my little dance party. So as you can see, I could keep going and make it last longer, or add in some more dancers, or maybe play some different songs and have different movements depending on the song. You can do all kinds of things with that. It's a lot of fun though. Just name one like that there. And then for our concept that starts in grade 3, we now have repeating events. And depending on what you've been doing so far, you may already start to see the need for some repetition to help us out to make our coding more efficient. So an unplugged example you could do is to create dance choreography or clapping, drumming rhythms that repeat. So you could have, one half of your class clap one rhythm and repeat it, and the other half of the class picks a different rhythm that they clap and repeat, and then you do it all together and hear how it sounds. Or the same thing with dance choreography. You could have a certain set of movements that one person does, and a different set of movements that someone else does, but then at a certain point you repeat and you do it over and over. And the reason for repetition is that it makes things more efficient, it makes things easier. If you had to learn dance choreography and from the beginning of the song to the end of the song nothing was repeated, you'd have a really hard time learning it, really hard time remembering it. So repetition is natural and helpful, and we see it everywhere, even in patterns of clothing or different places. So our code.org example this time is something a lot of my little girls in grade 1 just loved. They loved Frozen. So I'm Elsa of Arendelle. Help me create a single line. So there she is, and we need to make this line. So when we run, we're going to move forward by 100 pixels. And there we go. So far no repeating yet, but we're going to get there. They're teaching us step by step. So now I need to be able to do more than just going forward. I'm going to need to be able to turn the end of that line and then move forward again. And again, if I wasn't sure if it was right or left, I could just try it. Trial and error and find out. Okay, seems like we're halfway to making a square. Let's see if we can do all of the sides. Now this is where you start to notice the pattern. We're moving forward and then turning right, and moving forward and turning right. We're kind of repeating ourselves, aren't we? Oh, I guess I didn't need that last one. There's a counter right here that says 8 out of 8 blocks. That lets you know if you've added too many. That's a good hint if you're not sure if what you're doing is right. Now, this video is going to introduce your students to the concept of loops. Now, loops is the word a lot of computer programming languages uses to just describe repeating events and how to create them. So before, we had to say 4 times the same things in a row. You know, move forward, turn right, move forward, turn right. 1 for each side of the square. So they're showing us we could do it actually in a more efficient way by using a loop, this repeat block right here. So the only thing we have to do is say how many times we should repeat. And I've kind of already given away the answer. It's 4. But again, you know, maybe our students don't catch on to that right away. That's okay. If they just said 3 and hit run, they can see the immediate results of what they chose. And then they'll go, oh, that wasn't enough. So they can just reset, try again. So you can start to see that last time it took me 8 blocks to do the same thing, and now I could do it with just 4. So it starts to become a lot easier to use repeat blocks. So this one becomes very important to read the instructions because it helps us out not to get too stuck. Let's create 3 squares, turning after each square. Be sure to turn by 120 degrees. So if we're creating 3 squares, I think we're going to repeat 3 times. And right here, turn right by 120 degrees. I do have students get stuck on this particular level sometimes because they forget to read the instructions and then they get stuck having to do trial and error on all of these. But again, they'll get there eventually. So here we go, we're repeating, and we've actually even started doing something from the grade 4 specific expectation, which is okay, which is using nested loops, a loop within a loop, to do something really cool. But that's all right. Like I said with coding, it's very hard to just find something that's specifically like grade 1 or grade 2 or grade 3 because you're using those skills across all of them very easily. So I'm going to challenge you to do the same thing here. If you're following along, pause the video, go click on the link to the frozen levels and see if you can try them all. All right, how did that go? Fun, right? You can do some really cool things. And our primary students may not get all the way through all of the levels. A lot of them will. I've had grade 1s and even kindergarten students finish all of those levels. But if they don't quite make it to the end, that's all right. They've still practiced and learned that repeating concept, even if they only finish the first half of the levels. So we could do a very similar thing with Scratch. First, I want to revisit our dance party here for a second, because I hope you started to notice that our dance party could actually work really well if instead of just saying next costume and wait, we actually use some repeat blocks. And in Scratch, it says forever because it's repeating forever. You could also have it repeat a certain number of times if you wanted. I'm actually going to repeat our song as well. It's going to keep playing it over and over. And now I'm going to go back to the other character. And I just need to identify that one unit of my pattern. That's the tricky part sometimes. Put just one unit of my pattern inside the repeat block. Get rid of the rest. And now when I hit go, my dancers are just going to keep going forever and ever and ever until I hit stop. So that's fun too. But you could also do the same thing that we just did with our frozen characters, and we could draw shapes right here on Scratch. So to draw things, we're actually going to go down to the bottom left here, and there's some add-ons or extensions. I'm going to add the pen blocks. Give us some options for drawing. So I'm going to set my pen color to purple, because why not? I'm going to put my pen down on the paper. And then you draw by moving, much like you did on code.org. Let's move at 250 steps. Then I'm going to turn, come back in, cat, by 90 degrees. And I'm going to repeat that 4 times. What shape am I drawing? Can you tell? And a couple of other things I'm going to do. You notice that I've already drawn a bit because I clicked on things by accident. It can help to put an erase all block at the beginning so it erases everything every time you start. And then the last thing I need, just the block to tell it to go when I hit the flag. There we go. I drew a square. Now, my character is a little crooked. I could probably fix it if I wanted to. There we go. Perfect. So it's all about that trial and error. So I did it once, I noticed my square was crooked. I had to think through, why did that happen? And does it matter? Do I need it to be straight? And then problem solving of, well, where would I go to fix that? And the more you play with Scratch and coding, the more you'll learn these little tricks, and it will start to become easier and easier, just because you can pull on that prior knowledge. All right, so there you go. So now you could actually challenge students to do that second half of the curriculum. The first half is that specific expectation that asks them to create code, but they also need to be able to do that second part, which is to look at code that's already written, modify it, and figure out how their changes have impacted the code. So if I change this to instead repeat 3 times, how would that impact my code? Can I predict what will happen before I even hit that go button? What will happen? Do you have a prediction? Let's try it. Okay, so it drew 3 sides of a square. Now, what if I change this number, the 90 degrees? What if I change it to 120? What will happen now? Do you have a prediction? So this time I made a triangle instead. Then you could think, well, how could I modify this code to make other shapes? How could I make a rectangle instead? How could I make a parallelogram? How could I make, name any shape, and you could try to modify the code to make what you'd like. And you can learn a lot about the properties of shapes through doing it, which is cool. All right, so some tips and tricks, some things that I found helpful. Here's my top 3. Pair programming is awesome. That's when you get 2 students working on one device together. Now I know with our current situation, that might not be possible or maybe trickier than usual. But in a typical situation, I would have one student in the driver's seat and another student telling them what to do. And that second set of eyes and perspective can really help with that growth mindset. Because if you're stuck for ideas, chances are is that your partner has an idea. And together, 2 heads are better than one. You can really move forward and progress and not get stuck, which is awesome. And in the real world, that's what they do. Nobody codes things all by themselves. They're working in teams and helping each other. As a teacher, don't feel like you need to be the expert. Don't feel like you need to spend hours and hours studying Scratch and learning what every block does and having all the answers. My students teach me things all the time. And yes, I play with it too because I do want to feel like I have a little bit of a background, but you don't have to stay one step ahead of them. In fact, it's great when they kind of run with it and take off, and that's just awesome. Do also balance your instruction around coding with some, directed, solve this problem, draw a square. But also have some time for some open-ended exploration where the students get to define their own problem and figure out how to solve it. And that can be a lot of fun for them and very creative as well. So you need both, but a balance is awesome. And you'll be really surprised with the cool things they can create when you just kind of set them free and say, okay, here's Scratch. You have half an hour. What can you make? And they'll discover all kinds of cool new things. Now, it can be intimidating as a teacher when you don't know the answers and the student comes to you and they say, I'm stuck, please help. And you want to be able to help them, but just by prompting their thinking, you can often get them to solve the problem themselves without you needing to necessarily know the answer yourself. So the first thing I often say to students is, talk to me about what you've tried already. Show me your steps. And often just by them slowly having to go back and explain it out loud, they find that mistake all on their own without you even having to do anything. Another thing that can help is to act it out, especially with those maze levels with our grade 1 students who are first beginning and they're having trouble with left and right. Just physically acting it out can help. So you get them to read their code out loud and you can pretend to be that angry bird and you can move forward and turn right and do exactly what their code says. And just by them seeing you do it physically, it can help them make that connection as to what they need to change to figure out their mistake. This next one I've already talked to you about as we were doing things, but that strategy of adding just one block and testing it. If you add tons and tons at once, it's easy to get confused. And then this is the top tech tip of all time. When things aren't working well, and sometimes there's just no logical explanation for it, sometimes the website is just glitched. Refresh the page, try it again. You may not be doing anything wrong, and so that's often the last resort, but sometimes just a magical fix of things. This next trick I'm not going to play for you right now, but you can refer to it in the slide. When you're working with our younger ones and you need them to get to very specific levels on code.org, for example, it can be hard for them to navigate that website and find exactly where they need to go, and even just typing in the address can be prone to mistakes. So you can actually make some bookmarks on your tablets if you're using iPads, or if you're on a Chromebook, you can email them or post them that link, but making bookmarks really helps. That way there's no frustration with just getting started. And some further learning. I've started this informal group of teachers that's kind of working together and learning things. So you're welcome to join our Scratch class, and I've created some further tutorial videos if you're interested in learning a bit more about coding yourself. So feel free to join me there. The Learning Partnership also has a great program called Coding Quest that you can sign up for. It's free. I was involved with the creation of it way back when, and they've revised it. It's even better since then. But it can help you if you're feeling like you need more of a teacher's guide for how to go about this. Go and check that out. And lastly, CS First is a set of lessons that gives some tutorials for Scratch. So again, you could have students follow along step by step and create some really cool things. So thank you so much. I appreciate you taking the time to learn a bit more with me. Because this was pre-recorded, of course you didn't have a chance to ask questions live, but feel free to reach out to me on Twitter or by email, and I will be glad to try to help point you in the right direction. So thank you very much. Appreciate it.